2, we are given a particular trig identity. So if this was an exam question, I would imagine that in part A, you would prove that trig identity using De Moivre's theorem. And we actually did do that in the previous lesson. If you turn back your pack 2 or 3 pages, you will see a proof of that. So I'm assuming you are now okay with proving that kind of identity. The purpose of this equation is to work out the third value of cos of pi over 8. Now, I think this is very difficult to see how to use this trig identity to prove that without giving a hint. And this is my hint. I am going to consider the equation cos 4 theta is 0. And I'm actually going to solve this in 2 different ways. One of the ways cos of pi over 8 will turn up. Using the other way will enable me to work out what the exact value of cos pi over 8 is. So if I consider the equation, so I think this question would be very difficult in an exam without giving you that hint. So there's my hint. So I'm going to consider the equation cos 4 theta is 0. So cos 4 theta is equal to 0. So using my trig identity, I know that this means that 8 cos to the 4 theta minus 8 cos squared theta plus 1 is equal to 0. And that, my friends, is a disguised quadratic equation. It's a quadratic equation where x is cos squared and therefore b is x squared is cos to the 4. So if you solve that on your calculator, you can get the value of cos squared theta. So this is using a is 8, b is minus 8, and c is 1. This solves to give cos squared theta is the 2 exact third roots are 2 plus or minus root 2 over 4. So consequently, that means that cos theta is equal to plus or minus the square root of 2 plus or minus root 2 over 4. So whatever the values of theta are, the value of cos theta for any angle which satisfies that equation must be this. Okay, I'm now going to solve this equation in another way because it's not a complicated trig equation. To solve cos theta is equal to 4, you inverse cos and then divide by 4. So this means that 4 theta is inverse cos of 0, which, working in radians, your calculator will give you as pi over 2 or half pi. Now, because this is a power 4 equation, I am going to write down 4 other solutions. So if you think about the graph of cos for a minute, here is the graph of cos. It's 0 at pi over 2. That point is 2 pi, so that point is 3 pi over 2. And then it repeats every pi after that. So it's pi over 2, 3 pi over 2, 5 pi over 2, or 7 pi over 2. So consequently, theta must be pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8. That's divided then by 4. So what that means is we've shown that the 4 roots of this equation are given by this. Let me highlight that. But solving the equation just by doing trigonometry shows me that the values of cos theta are cos pi over 8, cos of 3 pi over 8, cos of 5 pi over 8, or cos of 7 pi over 8. Because the equation is solved when cos theta is equal to these surds. The equation is solved when theta is these angles, so cos theta is that. And cos pi over 8 is one of these solutions. That's what we're looking for. So what this means is that cos of pi over 8 is one of the following exact values, plus or minus the square root of 2 plus or minus root 2 over 2. So if I can justify which of the plus or minus 4 numbers there are hidden in there, because you could do plus or minus underneath the square root to give you 2 surds under the square root, and then each of those can be made positive or negative. There were 4 surds there. Which one of those is it? And if I can justify this, then I can write it down. And this comes from the following logic, just looking at the graph of cos, but only for angles between 0 and pi. So the graph of cos between 0 and pi looks like this. Cos, I've got pi over 8 here. So cos pi over 8 there. I've got 3 pi over 8 here. Cos 3 pi over 8's there. I've got 5 pi over 8. So cos 5 pi over 8's there, which is negative, and 7 pi over 8. So cos 7 pi over 8 is there. So the 4 cos values correspond to these 4 values between plus or minus 1. And what we can see is that because cos is a decreasing function, cos of pi over 8 is the most positive of these 4 surds. So as cos x decreases on the interval between 0 and pi, cos of pi over 8 is the most positive surd. Most. So consequently, the exact value of cos pi over 8 must be, to make this surd as positive as possible, you want a plus sign underneath the square root to make the surd underneath the square root as big as possible, and then a plus sign afterwards. So the exact value of cos pi over 8 is the positive square root of 2 plus root 2 over 2. Okay, folks, you're now in a position where you can do exercise 8. Can I just give a little bit of warning for exercise 8? So these tend to be questions, they're all old exam questions. The first part in each case is getting you to use de Moivre's theorem to prove an identity of the form cos n theta, sine n theta, or tan n theta equals something. And then in each case, there are extra parts asking you to do things generally involving polynomial equations. My advice would be, if you are confident with the first part of these, how to use de Moivre's theorem to prove these trig identities, then you can take them for granted and just worry about the second part. Each of the second parts are a little bit different. They're not done in exactly the same way. They are problem-solving questions. They are challenging. If you find that difficult, check the model solutions. Okay, folks, we're done.